let's sketch the graph of this rational function using the steps written on the right. So this function is x squared minus 4 divided by x squared minus 1. I also gave you the factor form of the function. The first step is we will have to find the domain of f. So let's write this down. So we are finding the domain of f. So what do we have to look at? We have to look at the denominator, right? So the denominator, we have x plus 1 and x minus 1. So since this is a rational function, denominator cannot be equal to 0, then x plus 1 times x minus 1 cannot be equal to 0. Therefore, x cannot be equal to -1 and x cannot be equal to 1. And then here is your intervals for domain. So we go from -infinity all the way to -1, and then from -1 to 1, and then from 1 to positive infinity. So this is the domain of the given function. And then the next step is the x-intercept and y-intercept, right? So let's use a different color to divide this up. So for x-intercept, you let y equals to 0. So y is equals to 0. We have x squared minus 4 divided by x squared minus 1. In this kind of situation, the top divided by bottom equals to 0. The bottom cannot be equal to 0. Therefore, the top must be equal to 0. Another way to think about this is you multiply the denominator on both sides to get 0 equals to x squared minus 4. So we have x0 equals to x squared minus 4. So that is equals to x plus 2 and x minus 2, right? So 0 equals to x plus 2 times x minus 2. So therefore, x equals to -2 and 2. This is one individual number. They are not x-intercept. You have to put this on x and y coordinates. So 2 comma 0 and -2 comma 0. So these two are the x-intercepts. And then the next one is the y-intercept. Y-intercept is easy. So for y-intercept, you let x equals to 0, so let x equals to 0, then y equals to 0 minus 4 divided by 0 minus 1, that is equals to 4, so 0 comma 4 is your y-intercept. And then moving on to the next step, we have horizontal asymptote and vertical asymptote. So for horizontal asymptote, let's do vertical asymptote first, because the domain tells me what the vertical asymptote is. Do you still remember that for the domain, x cannot be equals to 1 and -1? Because when x equals to these two numbers, the function is not defined. So therefore, x equals to 1 and x equals to -1. So they are, let's put the -1. -1, they are my vertical asymptote. So I'm going to box this. And then how about horizontal asymptote? So for horizontal asymptote, you have to use limit. So for horizontal asymptote, you have to set the limit and then let x goes to positive infinity. So for horizontal asymptote, you have to look all the way to the right end and the left end of the function. So that's why x goes to infinity. And then you have x squared minus 4 divided by x squared minus 1. And then to solve this limit, you have to divide each term by x raised to the highest degree in the denominator. So that is, you multiply 1 divided by x squared and 1 divided by x squared. Alright, so divide each term by x squared, then you have limit as x approaches to infinity, x squared divided by x squared minus 4 divided by x squared, and then x squared divided by x squared minus 1 divided by x squared. So you have a limit as x approaches to infinity. You have 1 minus 4 divided by x squared and 1 minus 1 divided by x squared. So as soon as x goes to infinity, all the fractions become 0. Then you have 1 minus 0 divided by 1 minus 0. So that is equals to 1. So y equals to 1 is my horizontal asymptote. And of course, if you let x approaches to negative infinity, y approaches to 1 as well. So HA and VA, they are done. And then the next step, we will have to move on to the maximum and minimum. So for the maximum and minimum, we will be analyzing slope. So for slope, you have to find the first derivative. So this is a rational function. Of course, the derivative requires using quotient rule. So I'm not going to make the video too long. So to make the video shorter, like save myself like 3 to 4 minutes, I will just go straight to the derivatives. So here, I am going to go straight to the derivative. I will just say f prime of x is 6x divided by x squared minus 1 squared. Okay, we have done so many derivatives. If you cannot do derivatives at all, you are in the wrong lesson. You have to go back to the previous to the derivative lessons, the quotient rule lessons on my channel to review quotient rule. Okay, so quotient rule, I expect everybody can do quotient rule. And then you set this equals to 0. So you set that equals to 0. So 6x divided by the bottom equals to 0. So therefore 6x has to be equals to 0. Then x equals to 0. So this is my critical number. So make sure the function is defined in this critical number. Okay, so when x is equals to 0, the function is equals to 4. Y is equals to 4. And then now you use the domain and the critical numbers to build your test interval. So I'm going to draw a number line. We have -1 and 1, right? So -1, and then we add a 0 to it, and then a 1. So that breaks down into 4 intervals, from -infinity to -1, from -1 to 0, from 0 to 1, and then from 1 to positive infinity. This is a sign chart. Write this down. This is a sign chart. And then you will be selecting your test value. So x equals to -2, x equals to -0.5, and then this one positive 0.5, this one I pick a 2. And then since we are analyzing slope, then you will be plugging into f prime of x. So f prime of -2, f prime of -0.5, f prime of 0.5. The last one is f prime of 2. So you plug it in and then evaluate what that equals to. So that is -1.33. This is a -5.53. This is a positive 5.53. And this is a positive 1.33. So negative slopes, we have going down and then going down. Positive slope is going up, positive slope is going up. And then don't forget that x equals to -1 and 1. So these two, they are vertical asymptote, and this one is also a vertical asymptote. So this is x equals to -1, this is x equals to 1, and they are not minimum or maximum anyway. And then do we have any min and max? The answer is yes, we do. So we have x equals to 0. This is a relative minimum, right? When x is equals to 0, we have a horizontal tangent line, and then decreasing, increasing, therefore we get a minimum. Okay, so we have one relative minimum. And then what about the double prime? I already did the double prime. I don't think the double prime will give you a lot of help for the graphing. So let me give you the double prime. So double prime, switch to another color first. So for double prime, same thing. I will go straight to the derivative using quotient rule. So that is equals to negative, and then you have 6, and then 3x squared plus 1 divided by x squared minus 1 to the third power. So this one, if you're asking me square the denominator of the first derivative, that is supposed to be the fourth power. If you simplify the numerator and do a factor, that can reduce the denominator, the fourth power, by 1. And then to find the inflection point, we have to set this equals to 0, and then top divided by the bottom equals to 0. So therefore the top must be equals to 0. 3x squared plus 1 equals to 0. Do we have solutions for this? Can 3x, you square a number, multiply a positive that is absolutely positive, right? And then you add 1 to it, can that be equal to 0? No. Even though you pick x equals to 0, so you cannot get a 0, right? You square a number, you multiply by 3, and then you add 1 to it, that is always positive. You will never get a 0. So that means this has no solution. And therefore, this second derivative gives me no critical number. Okay, and then what about for the chart? to testing the concavity, concave up and concave down, that one is not going to give you anything useful. If you want to do the testing, you can use this. You can use this number line for the testing, except you are testing using the second derivative. For each test value, you have to put that to the second derivative. Okay, so use the same test interval, but when you do the testing, plug in the test value to the second derivative. That is not going to give you a lot of help. So we can go straight to the graphing. So let me get rid of that. All right, so let's go straight to the graphing. So let me sketch the horizontal and vertical axis first. Let's use green. So this is my horizontal axis. Is the line straight enough? So we have a horizontal axis. This is my x-axis, and my vertical axis is my y-axis. Okay, let me just do this, because we need to make sure the graph is nice and big. All right, what is your horizontal asymptote? Your horizontal asymptote is y equals to 1. Let's get that. So y equals to 1. So we have here y equals to 1. So horizontal asymptote, use a dashed line. And this is y equals to 1, right? And then two vertical asymptote, one at x equals to 1, one at x equals to -1. Okay, let's do that. So one at x equals to 1. Oh, this is -1. And then one at x equals to 1. So this is x equals to 1. And x equals to -1. So the asymptotes are done. And then the next step, we have two x-intercepts, right? One at 2, one at -2. Okay, let's do that. So we have 1 at 2. So this one, then this will be a 2, right? So this is x equals to 2. And then this one is x equals to -2. All right, and then we have 1 y-asymptote, y-intercept at 0, 4. So 0, 4. So the 4 is right over there. Okay, so all the intercepts are done. Asymptotes are done. And then the first thing first, I would like to sketch the relative minimum. So do you see right here? When x equals to 0, we have a minimum. So going down and then go back up. So that tells me the graph looks like this. Going down and then going up. So we have a minimum. All right. And then x equals to -1 is the VA. And then on the left-hand side of the vertical asymptote, we have a graph that is going straight down. So going straight down. So do you see this? It's going down. So you are not going to get something like this, right? This is not going down. That is passive slope. So in order to go down, you must have this, right? And therefore, this piece will look like this. As x approaches to -infinity, y approaches to 1, and then this one is going up. So going up, you are not going to get something like this, right? That is not going up. That is going down. So going up, increasing. So we should get something like that. And then if you want to say more regarding the behavior when x approaches to -1 from the left and x approaches to 1 from the right, so here is what you can say. So as x approaches to -1, right? Okay, vertical asymptote at 1 and -1. So as x approaches to -1, so here, as x approaches to -1 from the left, what do we have here? So we have a -1 from the left, square, -4, right? So that is what y equals to. And then we have x squared, so this is a -1 square -1. -1. So the top, I am not going to worry about that. You square a -1 -4 is equals to a -3, right? -1 minus, so that will be a 1 minus 4, so that is a -3. What we need to worry about is at the bottom. So do you see that? negative 1. So negative 1 square is 1. 1 minus 4 is negative 3. To be honest, we don't really need to do this. So instead of doing x approaches to negative 1, so this one I will just erase it. I won't put this on my paper because using the sign chart that is already enough to sketch the graph. So this one, instead of doing something more complicated, let's forget it. So cut. Alright, so that is the end of this video. If you think my instruction is helpful and clear, give me a like, share the video for me. If you are new to the channel, click 2 seconds to click the subscribe button down below. I will see you all in the next one. Signing out.